All right, time for another video here. Um, we're still going through functions. Last video had to deal with scope, which that one kind of lasted a bit long, but it's fine. As we found out and stuff, there is a lot to deal with functions and how they can be used in so many different ways. But let's adjust the screen here and get started on this so we can get through this. Keep discovering, keep learning things. I'm more the one learning things and discovering things while I'm just sharing a journey with you. So here we are, on the right side, W3 Schools, left side, VS Code, um, learning about C++, and currently we're still in functions, of course, but currently we're doing recursion. Now, I don't recall this one, so this one may be kind of something I'm going to learn for the first time, but I'm not sure. Recursion. Recursion is a technique of making a function call itself. I think I've heard of that, but I'm not sure. Either way, let's go about learning it. This technique provides a way to break complicated problems down into simple problems which are easier to solve. Recursion may be a bit difficult to understand. The best way to figure out how it works is to experiment with it. I would say it's true for just about anything, not just this right here. But so here's a recursion example. Adding two numbers together is easy to do, but adding a range of numbers is more complicated. In the following example, recursion is used to add a range of numbers together by breaking it down into the simple task of adding two numbers. And then we got the example, so let's clean up this code right here real quick. Okay, so it looks like we have a function right here. Get this typed into here. So we have a integer type function. The name of the function is going to be sum with looks like one parameter of k. Looks like we're going to use an if statement. Um, what was that was called the parentheses for an if statement? The expression? No. Let's go back up here and look real quick so we know where we are. If statements. Condition. Condition. That's what it was called. Okay. So, we got the if statement, the condition. K is going to be greater than 0. As long as that's the case, then we can go ahead and run to the next line of the if statement. If it's false, then we skip the next line. I'm going to go ahead and use curly brackets on this. We're going to return k plus sum. Why doesn't that feel right? There. Maybe that, I don't know. This doesn't feel right. So we're going to return k plus sum, and then so yeah, with k minus 1, and in that, and come down here and add an else. Return 0. All right, and then we're going to jump down here to the main. No, okay. I got rid of the return for the main, but that's fine. So we're going to create another statement here. Integer result is sum with a parameter or with an argument of 10. I don't know why you jumping so far ahead like that. All right, and then we're going to output result, and then our return here of 0. Okay, go ahead and save that real quick, and let's check out what we got here for this example. So we obviously have an integer type of function with the name of sum with one parameter of integer type k as the variable. We got in the body, or the definition of this function is if k is greater than 0, which is the condition, return k plus sum. So this is where it's talking about recursion, because it's going to recall itself. So yeah, it's going to recall itself. We'll get into that here in a little bit, because that's a loop that that we won't understand until we finish understanding all this. So we're going to recall itself with k minus 1. If this right here is false, then we're going to skip to the else part and return 0. So 0 is going to be returned down to here, wherever. So in the main function, we got another integer result. So whatever k is, sorry, k, not k, but whatever the function returns is going to be right here. We got an argument right here of 10, so k is going to be 10. The next line right here, we're just going to output the result. So in this case, the first time we call it, we're going to have 10 right here, so k is going to be 10, which is going to be greater than 0. So then we're going to return k, which is 10, plus, then we're going to recall it again with this right here in there, k, which would be 10 minus 1, which would be 9. So this right here equates to 9, so that goes back into the k right there. And it looks like we're just going to continue this loop over and over and over. In this first case, though, it would be 10. The sum would be 10, or actually 9. That's the argument 9, but 10 would be the, I believe, so it would be k plus 10, which would make it 20, I believe. So we're going to return 20, print the result. I have a feeling, yeah, I'm not going to understand this right off the bat and stuff, because, yeah, like I said, it is kind of complicated because it loops back around, and I'm not sure what it's going to return. It should return something right off the bat, but it may not return anything right off the bat. So again, experimenting with this. Let's see what happens here. What kind of result we get? We get 55. Okay, so um, how do we get 55? Well, let's see. 10 up here. 10 is greater, so we go to the next line. 10 plus whatever this is. So k is currently 10 right now, plus the sum of this, which is 10 minus 1. Or not the sum of it, sorry, the return. So 10 minus 1 is 9. So now k is 9. We still got k as being 10 right here, plus whatever this is. That is going to be hard for me to figure out and stuff in my head alone. I'm going to do something different here to try to understand this. It's getting 55. I don't know how it's getting 55 because I don't know which is going first. I know this right here is going first, which is going to end up being 9. But we're calling it again, where it's going to be 10 minus 1, which is 9, into this. But what is this going to end up being right here? Because this returns to itself. So it returns this right here. Okay, so here's what we're going to do to try to understand this. This is not something we talked about, and probably not something this will explain. It is something that's explained elsewhere, though. The only other place I know it's explained is on the channel YouTube videos that I've watched in the past. And what I'm doing is I'm creating a breakpoint right here. So the program's going to stop right there when I debug it. So I'm going to open this up, run it as a debug, and I'm going to watch and see what kind of happens up here. This is what's kind of happening. So result right now does not actually have a value to it. Literally doesn't. Even though it shows this right here, I don't know what that is exactly. But we're going to keep going forward through it and step through it and see what happens. So k is 10 is equal to 10 at this point in time. We haven't run this one yet. Uh, now we know k is 10 because of this down here. We ran that, so that came out true. So we're going to skip to the next part right there. What does that come up to? Which runs back to that right there. It just kind of cycles back and forth again and again and again, which that's kind of what I was expecting. We don't actually have a value for. Now it's false. So are we literally adding every number from 10 to 0 to get our result, which would be 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. I guess that would come up to 55. Let's see, 19, 27, 34. I don't know. Let's see here. Get the old calculator out here. So it'd be 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4, 3, 2, 1. Yep, and that's what it would be. So k is consistently being added to itself after it loses one value every time until it comes down to where k is 0. And the return is all those sums added together. So if we keep dancing through this, we finally get to the end. And it's literally adding those numbers back up to itself, I guess. Going back through it. So before it even gets down to here, it's adding 1, 2, 3, 4, 5, 6 from that. Let's see, can we step back? No, we can't. So we'd have to run it again to watch that, but. So before it actually leaves the function because of the if statement, it's looping back around over and over again, just right here though. Then it returns 0, so it stops finally. But before it leaves the function, it's like it has k plus 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 k plus k plus k plus k before it actually exit the function. You can go ahead and stop that, close that down, exit that, get rid of my breakpoint right there. So it's like k's gotten multiple values to it before it exits the function. It's got 10, 9, 8, 7, 6 all the way down to 0. And before it leaves the function, it actually is adding all those together since that's what it's meant to do right here. And by the time it gets them all added together, it actually finally has a return for what this function is, which then can be printed up as 55 right here. But let's go back to over here, and we have a example explained area. So even if I said something wrong, it looks like it's going to explain exactly right here. When the sum function is called, it adds parameters k to the sum of all numbers smaller than k and returns the result. When k becomes 0, the function just returns 0. When we're running, the program follows these steps. So 10 plus the function 9, function argument 9, 10 plus 9 plus function argument 8, 10 plus 9 plus 8 plus, so it just, yeah, that makes a lot of sense. And I'm not saying that sarcastically either. It does make sense. Because it's repeatedly adding itself again and again and again. So it's taking this right here and put it into parentheses to add it again and again and again, everlasting. And then finally when k ends up being 0, whatever this is right here actually gets returned at the end. of the loop right down here. Since the function does not call itself when k is 0, the program stops there and returns the results. So that would, in another sense, that is quite complicated because first off, you have to understand how that's working. And yes, it shows a very good example right here how that's working. That's kind of what I was thinking. But I mean, I don't go by assumptions too often. So um, not only is it sorry, not only is it complicated to understand what the code is doing, but then you got the other problem here. And what I'm thinking about in my head is if you needed to use something like this, first off, where would you ever need to use something like this? And then how would you come up with something like this to build as far as a program is concerned to use it for occasion like that? That would have to be somebody that's really good um, with trying to figure out solutions to problems with math. So I'm sure that this was something that was created a long time ago um, by probably math professors and people that were studying code. They came together and stuff and said, you know what, if you need to figure out how to do that and stuff, I could write a program that'll do that. I just need to know what you're exactly trying to do. I guess I don't know. I couldn't imagine to understand that. But we got a yellow section here. Let's see what the yellow section comes up. The developer should be very careful with recursion as it can be quite to easy to slip into writing a function which never terminates, or one that uses excessive amounts of memory or processor power. And I can see that because if this number is a lot bigger than what it is for just 10, I mean, that's a lot of numbers to put together and a lot of memory to have to use because it's consistently have to create a new location for k every single time because k has a new value every time. Either that or else it's constantly having to put a new integer into the variable k location, which then if it ends up overloading that location and stuff, it's going to have to move on to another location, which then can end up starting to clog up the memory. And the processor is going to be quite busy doing all this right here to see what the final output is while storing all that. Okay, so however, when writing correctly, recursions can be very efficient and mathematically elegant approach to programming. And yes, I can kind of see that, especially with games you play and stuff, because if you have multiple, so think of any game you play whatsoever. If you have multiple attacks, and I'm sure you've heard of the idea of a combo. Well, a combo I think would be the same thing. One attack after another, comboing into 5 or 10 different attacks, and then it adds them all up to give you the total damage done at that point in time. And then exit the function and move on to the next phase, waiting on user input to determine what the next course of action is, unless it's something to where it's auto attacking and then you're just adding skills to it. So if you're playing a fighting game or a hero game and stuff to where you're doing multiple attacks and it's actually counting up a combo attack to where this character attacks and brings in this character to attack with it, and once that character gets done attacking, this character can bonus attack off of that character's attack. I mean, yeah. So I guess that yeah, that makes somewhat sense to me. Feel free to add something in the comments for that. Other examples where that may be used, if I'm saying something wrong about that, or if you have a question about that. I don't know if I can answer any questions about that or not, but yeah, um, that would be interesting to see people's opinion about that right there. I'm learning it for the first time, I think. I may have seen it once before, but I'm not sure. If I have, I've completely forgotten about it. Okay, so moving on to the next part, countdown. This example demonstrates how to use recursion to create a countdown function. So I'm going to have to yawn again. So we got another example here. We got a main function and a void function. So we're gonna go ahead and recreate this function here called a void function. I got a kitty cat that I think wants out of my room. I'll let it out here in a minute when I'm done with this video. Count down, and then we got still an integer, but we're going to remove that and give it n. We got the if statement still, but we're going to change the k to an n as well. We're going to leave the 0 there. We got the brackets there, but what is going to change is we're going to end up having an output since it's a void, so we're not going to actually have a return. So all this right here needs to be gone. We're going to go ahead and get rid of this right here because we're not returning anything. In fact, we're going to output in and then a space because we're going to have something else in there. We're going to end that statement and then do basically a thing where we recall the function from within the function to continue the countdown. Where we got n minus 1. Now, in a sense, if this kind of reminds me of doing, instead of doing the code this way, decrementing the code. So we have it so where we have n minus 1. What would be the difference between that and just have a n minus minus decrementing itself? It may be the same thing. I don't know. I'm going to have to work on understanding this better to see if that's even possible. In this case, down here in the main, now let's go ahead and finish writing this example. We got the countdown that we're going to call, and we're going to have an argument of 5, and then finish off that. Okay, so save that. Let's see if we can understand this one this time. So we're putting 5 in here for n. N is greater than 5, so we're going to output 5 and put a space. Then we're going to take 5 minus 1. So this is going to be that whole same situation and stuff where we have n, and then, no, because we're not adding to it. So we're going to have this output come out, then minus 1 from n, which is 5, and run it again. And then the next input is going to be 4. So we're going to have n, or 5, 4, 3, 2, etc. And all that is going to be put into here. This time, though, we are actually not, since we are calling this, no, it's not going to come back to here, my bad. It's not, because we're not returning it. So it's just going to continuously run the same thing over and over, 5, 4, 3, with a space in between, and nothing's going to come out at the end. We could do the whole Happy New Year thing where you add the standard output right here to where when the countdown's done, it could say whatever. But we're not going to put that in there because you should already know about that. So we're going to go ahead and save it, run it, and we should have, yep, 5, 4, 3, 2, 1. And I've shown you this before right here. This is the way to get it to count down or count up using the space, but if you wanted to go instead of across the screen, if you want to go down the screen, you would put next line. The function calls itself n minus 1 until n is 0. So yeah, you just keep going. If you want to change this value right here to make it to where it keeps counting up, honestly, if you took this right here and switched it, you would have that whole issue of that memory thing until n was less than whatever. But in this case, if we do have 0 in there, it actually wouldn't run at the start at all, because that's false. 5 is not less than 0. It wouldn't run at all. But if you put like negative 100 in there, then this is going to run forever until it reaches negative 100. I mean, you're going to have that countdown going for a long time right there, which means the processor is going to be doing a lot of stuff to continuously output, rerun this program, output, rerun, out, and yeah, it's going to last for a long time. So we're not going to save that and run that, but yeah, it's kind of an example of overtaxing the processor and filling up the memory and possibly having issues depending on how good your processor is or how much capacity your memory or RAM has, which is why I went with bigger memory and stuff. I wasn't intending on playing games with my PC. I was more intending on doing this, and I wanted plenty of memory capacity and stuff for something like this, just in case. Because it's a different story when you download a game than it is when you build a game yourself and then play it. Depending on how much space you need for the game to run on, which is why we use C++ and stuff to be sure that we're not overtaxing it by trying to get everything condensed as much as possible in the RAM without taking up too much of the RAM memory. Okay. Factorial of a number. This example uses a recursion function to calculate the factorial of 5. Now, I cannot remember, it's been too long since I was in school, I cannot remember what factorial means. I know it's a mathematical term, I believe, but I cannot remember what it means. Anyways, let's go ahead and copy this example into here. Int, we're going to change the name of it to factorial. It's still going to have the same parameter in it. We're going to change this. It's not going to be 0, but it's going to be 1 instead. And it's not going to be less than, it's going to be greater than. And in this case, we're going to get rid of this code because we are actually going to be returning something this time since we're changing it from a void to an integer function. So it's going to return n times, oops, factorial. So this is kind of the same thing as what we were doing before, or we're having the recursion stuff. And then down 1 for the else, and then return 1. So yeah, even when doing something like this, I do suggest if you're going to experiment with it, be careful. You always have the option of one, closing the terminal when this runs and stuff if it's overtaxing your processor or RAM. The other option you have is if you've messed something up to where it has overtaxed the memory of your computer to where you can simply shut things down and restart your computer and it should clear out the RAM. And then you can go back into the code and maybe see what you did wrong. Best bet on that though is to do more research on what you're trying to learn and figure out. Especially if you're not familiar with writing code, which is why I'm still going through this over and over and over. The last thing I need to do and stuff is do any damage to my computer besides what time is doing to it. That's not necessary. So we got the function done. I'm going to go ahead and change this out because this is no longer accurate anymore. So we're going to have a standard output here of factorial of 5 is with a space factorial, and then with the argument of 5. Make it a small number so that way it's not overtaxing things on the machine. Got it saved. In this case and stuff, we should still have a kind of the same thing and stuff to where it's multiplying instead of adding. And then we're going to have it subtract 1 each time. So we're going to start with 5. So 5 times, and this will be 4 times, and then it'll be 3, then times it'll be 2, then times it'll be, it'll stop at 2 because it'll make it false. It'll return 1, and then it'll do all the multiplication of 5 times 4 times 3 times 2. which I believe is, see, 5 times 4, 20. 20 times 3 is 60. 60 times 2 is 120. So this should end up becoming 120. It's going to return 1. I'm not sure. So when this is done, I'm not sure what that's going to look like with it returning 1, but we'll find out. Let's see here. Got it saved. Let's go ahead and run it. Let's see what happens here. Factorial 5 is 120, so I don't know what the return 1 is. Normally we have 0 in there, but I guess since we're stopping at 1, we're going to return 1. If we were stopping at 0, we would return 0. Again, more details on that on my other source and stuff, but for now, we've discovered it. Learning about it fully and stuff, we're not going to, it's not being done here. We need a better understanding of it. We need more examples of it. Play around with it, so forth, so on, keep going. And that's what we're going to do. We're going to move on. So factorial means multiplying a number by every number below it. Thank you. Now I kind of remember or have an understanding of it. Down to 1. For example, the factorial of 5 is 5 times 4 times 3 times 2 times 1. That's why you're returning 1, because you want to also multiply it by 1. That's where the 1's coming in play. If you multiply it by 0, you get 0. And I guarantee if we change this to 0, we're going to end up with 0 as our final result. Yep. Because at the very end, it ended up multiplying by 0. So you got to have 1 in there. So it doesn't do that. Multiplying anything by 1 is the original value. Moving on. All right, that's not too bad. That section right there took about 30 minutes. I'm going to go ahead and end the video there. Yeah. You can change some things around in here and stuff, but be sure that you don't overtax. I just caution on that. Don't overtax your CPU. Don't overtax your RAM. Like I said, worst case scenario, you stop the program if you're having issues with it slowing down or something like that. Most likely you've overtaxed the memory. In that case and stuff, just go ahead and close everything down and restart the PC. That way it clears out the memory, or at least hopefully it clears out the memory. But using the examples, they shouldn't be too far off with that. Again, I don't know how this would be used in something. If you were, yeah, the imagination can come with many different ways of how to do things. But so when we come back to our next video and stuff, we'll talk about lambdas functions. And I'm still not sure if I fully understand lambdas. I know I've seen it many times already, but I keep forgetting what it is and how to use it so many times. So when we come back, we'll get into lambda functions. Once we do that video and stuff, that'll be the end of our functions video, and we'll be moving on to classes after that for C++. Like I said, any comments, any questions, any corrections you want to make to something I've said or done, anything you want to add, perfectly fine. Just put it in the comments there. I have no problem with that. If you like the videos, hit the like button. Otherwise, I will see you next time.